Okay, I'm back, and so now you should have calculated the spring constant of that spring that we used last time. Alright, now what we're going to do is we're going to pull that spring down a little bit and then let it go. So I'm going to move this over here so that you can see that spring. Okay, and now I'm going to grab it, I'm going to pull it down a little bit, I'm going to let it go, and can you see it oscillating up and down? Okay, I'm going to do that one more time, and now this time what I want you to do is to click your stopwatch whenever you see it start to move, and then you're going to count how many times does it go up and down. So what we want it to do is we want it to go, it's going to start down here, it's going to go all the way up to the top, and then it's going to come back down again. So that would be one oscillation. Now you need to time how long does it take to make 10 oscillations. So it's going to go up and down 10 times. Okay? So you got out your stopwatch or your cell phone? Okay. So here we go. Okay, so that was more than 10 oscillations. So that you needed to have clicked your stopwatch off whenever it came back down for the 10th time. But I did it for more than 10. Okay, so now you can, okay, let's go back to the lab now. You should have recorded the amount of time it took to bounce 10 times. Okay, you're going to calculate the frequency using equation 15.1 because you know the number of times it bounced up and down, and you know the amount of time it took to bounce up and down, and so you can find the frequency that way. And then you're going to find the frequency using the equation for a spring. And in order to do that, you're going to need to know the mass that was bouncing up and down, but you have recorded that. And you have also measured the spring constant. Okay, now let's do the next equation, or the next thing here, that says what happens to the frequency if the mass is increased. Okay, so what I want you to do is to use your equation for the frequency of a spring, the one that depends on the spring constant. Okay, and then I want you to increase the mass that's in that formula. What comes out of the formula? So if you increase the mass in the equation, then what comes out? Does it get bigger or does it get smaller? Okay, now what we'll do is I will go back to the pendulum and I want you to see what happens. So you know what the frequency was. So let me do it this way. I'm going to take off some of the weights. Alright, so that is obviously lighter. Okay, now I'm going to pull it down. I'm going to let it go. Okay, and I want you just to see how fast is that thing oscillating up and down. You don't need to do any calculations, but just observe it. Okay, and then let's put more weight on it. And nope, that's all the weight I got. Okay, so I'm going to pull it down, I'm going to let it go. And you should be able to see a difference in the way that it's bouncing up and down compared to how it bounced up and down when it didn't have so much weight on it, so much mass on it. Okay, so that you're going to answer that question. Now, what happens to the frequency if a stiffer spring is used? Well, I just happen to have a stiffer spring. So this one was the light spring. Now this time we're going to use the same amount of mass. So let's do it one more time here. So this is going to be a spring that is not so stiff. So this is a more stretchy spring. So this one has the smaller spring constant. Okay, and again, that's how it oscillates. Okay, now I'm going to stop it. I'm going to use the same amount of mass. Wouldn't you know? Okay, I need to take off this little circle thingy. And then I'm going to put it on the big one, because it wouldn't fit over my pencil. Alright, so here is a stiffer spring. I'm going to put the same amount of mass on it, and I'm going to pull it down. Well, you can see what's happening there. Alright, do you see that it's vibrating much faster? As a matter of fact, it's not even really pulling that spring down. I need to put more weight on there in order to be able to do that, and I don't want to do that. Okay, then the last question is, what happens to the frequency if the spring is pulled out further? Alright, so I need to go back to my original loose spring. Okay, I'm going to go back to my original amount of mass. So now what I'm going to do this time is I'm going to pull it down just a little bit and then let it go. Okay, so observe what that frequency is. Now I want you to compare it to, again, this time I'm going to pull it down further and let it go. And look at what happened to the frequency, if anything. Now the amplitude is larger because I pulled it down further. But what we're interested in is the frequency. So answer that question. Alright, now we're going to stop the video, and when we come back we're going to go to part 3 of the lab, damped harmonic motion.